Welcome to section 9.16, part 2. This is the 88th session of the CISSP exam prep series. This part continues our tour of virtualization, moving from the building blocks into the wider software-defined world and how you keep it all secure. In this session, we'll cover the rest of the virtualization story. What does it mean to run everything as software? What are virtual desktops and thin clients? How does software-defined visibility in data centers fit in? How do you actually manage the security of virtual systems? What is VM sprawl, and where does shadow IT creep in? And what happens when a guest breaks out of its box? Why does this matter beyond the exam? Because your fleet is quietly turning into software. Picture a regional insurer that swaps racks of aging desktops for a central virtual environment. Suddenly storage, networking, and even employee workstations are all just files on a server. That agility is a gift, but every one of those virtual pieces still needs patching, isolation, and oversight. You are the person who makes sure the convenience does not become the breach. So what does it mean to run everything as software? This is the idea behind software-defined everything. The trend is simple. Take a piece of hardware and replace it with a software equivalent built on virtualization. Networking, storage, visibility, even whole data centers can become software you spin up and tear down on demand. Think of it like moving from a garage full of physical tools to a single tablet that can become any tool you need. The flexibility is huge, but so is the new attack surface. What are virtual desktops and thin clients? A virtual desktop infrastructure hosts each user's workstation as a virtual machine on a central server. People connect in from almost any device and see their familiar desktop. Some desktops are persistent, saving each user's customizations, and some are non-persistent, resetting to a clean state at every logoff. When you virtualize the mobile operating system itself on the server, that variation is called virtual mobile infrastructure. A thin client is the lightweight endpoint that connects to all this. It handles the screen, keyboard, and mouse, while the real computing happens back on the server. Picture a hotel room television. The screen is local, but the show streams from somewhere else entirely. How does software-defined visibility and data centers fit in? Software-defined visibility is a framework that automates network monitoring and response. The goal is to inspect every packet and make smart, automated decisions about forwarding, dropping, or reacting to a threat. It gives security teams and managed service providers a single pane of oversight across on-premises and cloud. A software-defined data center takes the idea to its limit. It replaces the physical elements of a whole data center with virtual services, often delivered by a cloud provider. Think of it as renting a fully furnished, ready-to-use office instead of buying the building and every desk yourself. How do you actually manage the security of virtual systems? Start with the hypervisor. The software that runs your virtual machines. It is an extra layer, so it is an extra attack surface, and compromising the physical host can expose every guest on it, harden that host, and use it for nothing but hosting. Then remember that virtualization does not erase the basics. Each guest operating system still needs its own patches, and so does the hypervisor. Keep tested backups and snapshots so you can roll back cleanly, and test the virtual systems just like physical ones, with vulnerability scans and penetration testing. Treat the host like the foundation of a building. If it cracks, every floor above it comes down. What is VM sprawl? And where does shadow IT creep in? Virtual machines are so easy to clone that they multiply faster than anyone can track. That is VM sprawl. Dozens of virtual systems running with no real oversight, each carrying the same licensing and patching burden as a physical one. The fix is a firm policy for how machines are built, plus a library of approved base images to deploy from. This connects to shadow IT, technology stood up by a team without the knowledge of management or the security group. Shadow IT skips your policies, misses patches, and quietly leaks sensitive data. Think of a spare fridge someone plugs in behind a filing cabinet. Nobody budgeted for it, nobody cleans it, and eventually something inside goes very wrong. What happens when a guest breaks out of its box? That is VM escaping. Software inside one guest defeats the isolation the hypervisor is supposed to enforce, reaching into other guests or the host itself. A well-known flaw exploited a shared virtual floppy driver to let malicious code jump between machines. The consequences can be severe, so defend in layers. Keep your most sensitive systems on separate physical hardware so isolation is real, not just logical. Patch every hypervisor the moment fixes arrive, and watch threat feeds for new escape techniques targeting your platform. Think of it as prisoners tunneling between cells. The stronger your walls, and the faster you spot fresh tunnels, the safer everyone stays. So let's bring it together. Software-defined, everything turns hardware into flexible software you provision on demand. Virtual desktops and thin clients centralize computing, while software-defined visibility and data centers extend the model to monitoring and whole facilities. Managing it all still means hardening the host, patching every guest and hypervisor, backing up, and testing. Watch for VM sprawl and shadow IT growing in the shadows, and defend against VM escaping with real isolation and fast patching. Get these habits right, and virtualization stays a strength rather than a soft spot. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.